Pandas offers powerful data structures like series and data frames, essential for data manipulation. Understanding these structures allows for efficient data handling and transformation. Mastering file operations, such as reading and writing CSVs, and applying cleaning techniques like handling missing values, are crucial for converting raw data into meaningful insights. Pandas series are one-dimensional labeled arrays, essential for data manipulation. They can hold diverse data types like integers, strings, and floats. Each element is indexed, allowing efficient access and manipulation. Series are crucial for building data frames and support powerful methods for statistical operations, filtering, and transformation, making them indispensable for data analysis. A Pandas series is a one-dimensional labeled array, ideal for holding diverse data types like integers, strings, and floats. Each element is indexed for efficient access and manipulation. Series are foundational to data frames, offering robust methods for analysis, including statistical operations, filtering, and transformation. They are essential for building complex data structures. The data frame is Pandas' core two-dimensional structure, akin to a spreadsheet or SQL table, with labeled rows and columns for intuitive data access. It supports heterogeneous data types across columns, enabling flexible operations like reshaping, slicing, and merging. This versatility makes data frames essential for complex data analysis tasks in Python. Pandas, built on NumPy, offers fast, vectorized operations, significantly outperforming traditional Python loops. Its intuitive API allows for readable and maintainable complex data manipulations, reducing development time. Seamlessly integrating with libraries like Matplotlib and scikit-learn, Pandas supports comprehensive data science workflows, making it an indispensable tool for data scientists. Reading data efficiently is crucial for data analysis. Pandas pd.read_CSV.function is versatile, allowing you to specify file paths, configure parameters like delimiters and headers, handle missing data, and preview imports. This ensures accurate data loading, setting the stage for effective analysis. Let's explore how to leverage these features for optimal data handling. CSV files are essential for data exchange. Use pd.read_CSV to load them efficiently. Specify file paths, configure delimiters, headers, and data types. Handle missing data with NA values. Validate imports using head, info, and describe. Example: load sales, data, CSV with specific columns, date parsing, and missing value handling for robust data analysis. Excel files, with their multi-sheet capabilities, are efficiently handled using pd.read_Excel. Specify the sheet with sheet name, select columns using usecols, and convert dates with parse dates. Ensure data consistency by defining column types with dtype. This approach allows precise control over data import, enhancing data integrity and analysis readiness. Handling large data sets efficiently involves chunking and memory optimization. By reading data in chunks, we process iteratively, filtering and transforming each segment. For instance, filtering revenue over 1,000 and optimizing data types like category to category and year to int16 reduces memory usage. Finally, combine chunks for a complete data set. Data cleaning is crucial for accurate analysis. Begin by identifying missing values using Pandas isNA and isNull functions. Calculate the percentage of missing data to assess impact. Remove rows or columns with excessive nulls, or fill missing values using methods like forward fill, mean imputation, or interpolation. These strategies ensure a cleaner, more reliable dataset. Handling missing data is crucial for accurate analysis. Use Pandas to identify nulls with isNA and isNull. Calculate missing data percentage, then decide on removal or imputation. Drop rows or columns with dropNA, or fill gaps using fillNA with constants, forward fill, or mean. Interpolation is also effective for numeric data. Identifying duplicates in datasets is crucial for accurate analysis. Use the duplicated method to find duplicates, specifying columns with the subset parameter. Remove duplicates with drop duplicates. choosing which occurrence to keep using the keep parameter. In customer databases, eliminating duplicates based on unique identifiers like emails or customer IDs ensures precise metrics and avoids redundant communications. Optimizing data types can significantly enhance efficiency, reducing memory usage by up to 90% and improving processing speed by 3.2 times. Convert repeated string values to categories and adjust numeric precision. For instance, use int16 for year and float32 for price. This approach can lead to substantial memory savings and faster data operations. Data manipulation and transformation are crucial for effective analysis. Pandas provides powerful tools like apply for custom transformations and vectorized operations for speed. Use Lambda functions for quick, inline tasks and custom functions for complex logic. Leverage vectorized operations for efficiency, significantly outperforming apply in speed. Pandas provides versatile methods for data transformation. The apply method allows custom row or column operations, while vectorized operations offer speed. Use Lambda functions for quick transformations, like converting prices. For complex logic, custom functions categorize data efficiently. Vectorized operations, such as multiplying columns, are significantly faster, enhancing performance in data manipulation tasks. The Group B operation in Pandas allows for powerful data analysis by splitting data into groups, applying functions, and combining results. For instance, regional sales can be summed using group-by-region revenue sum. Additionally, aggregating by multiple columns provides insights into revenue, quantity, and unique customers, aiding in strategic decision-making. Merging and joining data frames is crucial for data integration. Pandas merge function supports SQL-style joins, inner, left, right, and outer. Inner joins return rows with matching keys. Left joins preserve all left data frame rows. Right joins keep all right data frame rows, and outer joins include all rows, filling missing values with nan. Time series analysis in Pandas involves converting strings to datetime objects with pd.toDateTime, setting datetime as index for efficient operations, and resampling data to desired frequencies. Analyzing patterns like trends and seasonality is crucial. For instance, stock prices can be resampled to monthly averages and visualized with a 30-day moving average for insights. Visualization is crucial for deriving insights from data. Pandas, integrated with Matplotlib, offers versatile plotting functions. Use line plots for trends, bar plots for comparisons, scatter plots for relationships, and histograms for distributions. Customize plots with titles, labels, and colors to enhance clarity and impact. These visual tools facilitate a deeper understanding of complex datasets. Pandas offers built-in plotting functions through Matplotlib, enabling quick visualizations directly from data frames. Use scatter plots to analyze relationships, like advertising spend versus revenue. Customize with parameters such as alpha, color, and size. Explore various plot types: line for trends, bar for comparisons, histograms for distributions, and box plots for statistical insights. Multiple visualizations can be combined for comprehensive analysis. In this real-world example, we load customer data, addressing missing values by filling emails with unknown@domain.com and ages with the median. We remove duplicates based on customer ID and optimize data types for efficiency. Finally, we aggregate spending by customer segment, visualizing revenue insights with a bar plot to derive actionable business insights. Implementing best practices in data processing ensures efficient performance. Use vectorized operations to replace slow loops, reducing execution time significantly. Load only necessary columns to save memory. Convert repetitive string columns to categorical types for memory efficiency. Process large datasets in chunks to prevent memory overflow, ensuring smooth and fast data handling. Optimizing Pandas performance involves using vectorized operations instead of Python loops, which can speed up processes by 10 to 1,000 times. Load only necessary columns to save memory, and convert repeated string values to categorical D-type for efficiency. Process large files in chunks to prevent memory overflow, ensuring smooth data handling. Leverage A. iTools like GitHub Copilot or ChatGPT to generate Pandas code for data cleaning and transformations. Automate tasks with parameterized functions for handling missing values and duplicates. Use AI to accelerate learning by querying complex operations and receiving feedback on code efficiency and correctness. Intermediate Pandas skills empower you to transform raw data into strategic insights, forming a foundation for advanced analytics. Practice with real datasets, explore advanced features like multi-indexing and window functions, and engage with the community. Utilize essential resources like official documentation and Kaggle Learn to continue your journey towards Pandas mastery.